Good morning, good afternoon, good evening, wherever you are. Welcome to the technical specification, data types, format, and attributes. And this is a presentation of an MPAI standard that has been published for community comments and is expected to be published next Monday, 31st of September. Two words about MPAI. MPAI, what we are. We have international, unaffiliated, not-for-profit organization. We develop AI-based data coding standards, and we do that by providing, jointly with the standard, clear intellectual property right licensing frameworks. So let's examine each of these elements one by one. So our mission is the promotion of efficient use of data by developing technical specification for coding of any type of data, especially using new technologies such as artificial intelligence and technology that facilitate the integration of data coding and decoding components in information and communication technology system. So this is the development of technical specification. Next to it, we have the bridging of the gap between technical specification and their practical use by providing intellectual property right guidelines that we call framework license. We operate on the basis of an international collaboration of interested parties. We have members from 16 countries in the world. Each participant must support the MPAI mission and the means to accomplish it. So let's talk more about this IPR frameworks. So the intention is to make our standard accessible and timely available. So we do with this process. Before initiating a standard, we have principal members, we have principal and associate members, but only principal members can develop and adopt the framework license for that particular standard. And that is a license that is not a license because it does not contain values, it doesn't contain dollars, percentage, dates, but the license declares that the eventual license will be issued not after products are on the market and at a price comparable with similar standard technologies. During the development, any members, not just the principal, because associate and principal member can both participate on an equal standing to make contributions to the standard. So they have to declare that they make available their license, this is the real license, according to the framework license. After the development, MPAI facilitated the creation of patent pools, and we convene members holding in IP in the standard. They will select the preferred patent pool administrator, of course, without any participation on our side. We just give the opportunity for them to meet. Then we have how we develop practically the standards. So we have an 8-step process. We have proposals, then we collect interest about this proposal, we develop use cases, we develop functional requirements, and once we have them, we develop the commercial requirements, which are the framework license. Then we call for technologists, we develop the standard, and when the standard is ready, we publish it for community comment. Typically, it is 1 month, but in other cases, it is longer than that. And finally, when we receive comment, we try to incorporate any comment received into the technical specification that is published by the General Assembly. We also develop the reference software, the conformance testing, and the performance assessment. So this is the system whereby we develop standards. Our standards are supposed to be explainable. And so we have the idea of defining basic processing element. We call them AI modules. AI module can be basic in the sense that they cannot be further subdivided, or they can be composite. And we see here an example of the green boxes on the right-hand side of the figure represent a composite AI module. And when they are integrated in a particular environment that we will describe in a minute, they become AI workflows. So what we have done so far? Well, I would say significant number of results. So we have the result of this on a standard, on this AI framework, on audio, on connected autonomous vehicles, on finance, on human and machine communication, multimodal communication, on the metaverse. This has already been published, but we plan to publish a second part next Monday, on a neural network watermarking, on object and scene description. I describe objects and scenes and their spatial location and also time location, portable avatar format, profiles for AI modules, and what we are going to talk about today, which is data types, formats, and attributes. I will say more, of course, in a minute. So this are the areas where we are currently engaged in. So we have a new standard that have not been developed yet, and they will be developed for the first time. But if we take audio, we are working, for instance, on 6 degrees of freedom, and that is something that is a continuation of an existing standard. So then the basic question: what is this beast, this new beast called data type, formats, and attributes? So I've talked about the AI framework, and the AI framework is a basic component of MPAI standards. It is a framework that is called AI framework. It implements systems. They are called AI workflows, and AI workflows are composed of interconnected components. They are called AI modules. The AI modules communicate the data, and they do certain processing. By the way, our AI modules are only standardized in the sense that we know the interface, the input and output interface, and the function, but we don't know how this function is actually achieved. And the AIMs, this is the real motivation, can do a better job if they know more about the capabilities of the AIM they are connected to and the data they receive from other AIMs. And of course, then they have a duty to inform other AIMs of more features about the data that they transmit. So this is the full picture of the AI framework standards. It is there is a controller that is controlling the execution of the workflow. This is a workflow, and we have a number of APIs here that provide access to communication, to storage, to the MPAI store. I will not say more about this. And then we have 3 APIs for security purpose. SAL stands the security layer. So we have already developed one standard that helps AIM improve their performance. And this is achieved by means of profiles. Profiles is something that is well established in standardization. It is a collection of a subset of the technologies that are specified by a standard. So, explanation of how profiles are developed, have been developed, and we will develop more by MPAI. We take the natural language processing AIM. This AIM receives text from an automatic speech recognition AIM and produces refined text and meaning. So this is the very baseline function of this AIM. But the natural language processing AIM can have 3 levels of sophistication because it can produce recognized text and meaning uses. As I said, just the input text, also the object identities that are referenced in the text, or also the information about the space where the text that the text refers to. So these are different levels of sophistication, and it is obviously expected that for each level, the capability of the AIM improve in the sense that this natural language processing AIM can do a better job by having more sophisticated functions. So this was one way. This is a standard that we have developed. It's called AI modules. It is in the list that I have shown. But we can also improve the performance on AIM. And sometimes I must say, not just improve, basically enable, if the AIM knows more about the characteristic of the data received. And here I will give some example. But, you know, this is a very big world. And we are just scratching the surface with these examples. So, for instance, we want to say we have visual data, and we have to say information about the color space of this visual data. Or we have a speech segment, and we say that it is compressed in MP3. Or we want to say that, so, okay, we are receiving a file, but what is the format of that file? Well, it's a WAV file. This information is passed here. But we can also have more. For instance, what kind of gamma correction has been applied by the device that produced the video? And the instance ID, which is, okay, the identifier of an object in an audio segment. So you have an audio, you have a speech segment actually, and in that speech we are talking about an object. So we can give the ID of that object. In that case, we are helping understanding the content of the text. And then we can have just the text conveyed by a speech segment. So we have a speech, but we want to give what is inside the speech, which is the actual text. So MPAI-TFA is the standard for qualifiers. Qualifiers is the collection of all these things that I have said, but of course they are organized in a certain way. So the MPAI-TFA standard specifies the qualifier data type. Qualifier is a new data type that conveys, I'm giving further example, but because I needed to introduce the 3 basic elements of a qualifier, for instance, the color space. And that is an example of what we call the subtype, in the sense that we can have an image. That image can be in a color space or in another color space. It's still an image. So we define subtypes, the color space as the determining factor or the subtype of the image. Another example, what has produced, so the format that has been used to produce a video, and the kind of metadata, for instance, the Dublin core metadata that we use to describe the data. So we assume already, and this is a reality today, that most media exchanged by AIMs in MPAI are composed of content and qualifiers. So It means that we have content. Content is the data, as we usually call them, and then we have qualifiers. Now, the qualifiers improve the AIM operation by conveying information on subtypes, formats, and attributes related to the content. And another point, very important point, is that qualifiers are human readable, but they are intended only to be used by AIMs. As I said, qualifier is data about data that are expected to be used by an AIM. So it facilitates the operation of the target AIM. So we have developed in version 1.0, the one that formally is still for community comment. We have developed an initial set of qualifiers. And we have selected media because they are the most important element that we have. We have text, speech, audio, visual, 3D model. We also have audio visual, by the way. And qualifiers, as I said, have a hierarchical structure. So we have subtypes, formats, and attributes. And each element of subtype, format, and element may have a further hierarchy, but can also be missing. For instance, for text, we have not been able to identify subtypes so far, but we could define it in the future. A very important disclaimer must be made here, and that is that MPAI-TFA, the standard, is probably never going to be exhaustive, in the sense that we don't stuff everything that we are aware of in a qualifier. We are only adding those that are currently useful to us, but we can expect that there will be users of our standard who may need to have qualifier for other types of data that we did not consider. And therefore, new entries may be added at any time. And actually, next Monday, we expect to publish version 1.2 of MPAI-TFA, which deals with more with the different data types. So now I will give a very simple introduction by showing what is in the pages of the standard, which, by the way, you can find at this address. So this is how is the page. So if you go here, you will see that you have the data types. And so you see that we have text, speech, audio, visual, 3D model, and we also have audio visual. But here we are talking about the text. And let me go back to the slides. You will see that we have the formats. So we have identified the need to signal that the text is a static. And if it is a static, we have identified this standard as useful to us. But as I said, we could add more if that is needed. But this can also be dynamic. And we have identified time text ML and the web VDT as two standards that provide a way to represent the dynamic text. Then we have identified some attributes, and we have, for instance, object identity. This is one, what I was talking about before. So the text may talk about, I don't know, a die. And then I can give the idea of that object. Language. So we have identified the three major standards for language identification, and then we have also speech. And here we have, in the case of speech, we have as format. We have PCM, which is just the samples, and here we describe how the samples are represented. We give the sampling frequency, and the sampling and the sample precision. Then we have the compression format, and here we have indicated a few. Then we can also have transport. So transport is, well, here you'll see that for each word that you have the definition. Is the method used to transport speech. And what is transport speech? Well, you transport information, digital information in a file or in a stream. These are two ways. And so this is standard for all qualifiers. So in the case of file, we have identified the two types, which is WAV and MP4. And for stream, we have identified two, which is dash and HTTP live streaming. Then we also have attributes, and here we have the source type. That can be real and synthetic. We have the metadata about the language. So we have the speaker identity, as I was saying before. There's a speech, and we want to give the identity of the person who is speaking. Content description. So there is content. So it is text, and therefore here we have just selected ASCII and Unicode. And then we can also have the internal status, which is internal status is the method used to describe the internal status of a human or of an avatar. And in the case of MPAI, because this is part of an MPAI standard, it is cognitive state, emotion, and social attitude. And here you have the reference to our standard so that people understand exactly what we mean. Continue for speech. We have a device. What is this device? Well, the characteristic of the device that captured the speech. And which are the characteristics? It is the device ID. It is the device location. It is the sensor characteristics. So far, this is what we have. But then if we go to format is much more articulated data type. So we have what we call raw audio, which is what we call their PCM. And so this can be, the raw audio can be in sample space. So it's just the sequence of samples at a certain frequency. And then we also have the transfer space. So we can apply a Fourier transform of this audio signal, and we get audio in the transfer space. And we give certain characteristics here. Or we can have a spherical harmonic decomposition, which is yet another way of transforming the information into the transform space. And then we also have ambisonic. Then we also have compression formats, and we have several MP3, AAC, two types of MP3 and two types of AAC. Then we have the problem of transporting audio. So this can be done by, because we have a file and we have a stream and we have identified, well, this is a richer selection of file formats. And for the stream, we have the usual dash and HLS. Then for audio attributes, we have the source type. So this is important if you go deeper into the meaning of audio, not just as a samples of represented in whatever method, vocal, which is a combination of spoken and music, so like an opera, for instance, or a song. Then we have music. This is just music. We have also sound effect, and we can have noise. So these are all different types. And because MPAI digs very deep into the meaning of the data, all this information is very, very useful. Because, for instance, we can use certain data for certain purposes and other data for other purposes, and this can be signaled using qualifiers. Then we have metadata. So this is just this is data about data, and we have different ways. We have general like a doubling core or IV3. Then we have the spatial attributes, which is of course this has been developed by important experts in this field. It's about the characteristics and the binaural cues, the spectral cues, the interchannel differences. And then we have, we are again with the device with the same point. We have the device geometry. So in the case of audio, we can have a microphone array. Then we have the location, where in space is this device placed, and what are the characteristics of the sensor, and what is the and that is all. Then for visual we have here we have subtypes. This is the first case that we have subtype. So we have color, and we have several parameters: color format, alpha channel, brightness, the YUV of television, the subsampling. This is important for television. YMCK, which is the format used for in the printing industry. Then we have the formats. So again, we have the sampling. Then we have the case of 2D 2D visual information, and we have static and dynamic here, and we have 3D, and here too we have static and dynamic. Then we have transport, and we have a selection of transport methods for files and for stream, in particular, good old MPEG-2 transport stream as one possible way. Then we go to the attributes. So we have a source type. It can be real, it can be synthetic. Then we have metadata. We have visual metadata formats. We have the object ID, the entity internal status. Again, we can have an avatar here, and it is important to know, if this is already known, what is the internal status of this this avatar. And same for device, and here we have similar consideration as we had for speech and for audio. Then we have one. This is not the last one, but last 3D model. 3D model is a type of data organization used to represent a time-independent or time-dependent 3D model. So we have they can be static, they can be dynamic. Then we have this is the content side, and we have the transport, and and then we have attributes. So we have what is the source that again, it can be real or synthetic, and then we go to the last one, which is the audiovisual. So we wanted to be able to represent in JSON, because all this is specified in JSON. I will show you in a minute examples. So we want to be able to specify also the data type that is audio plus video. and we call that audiovisual. And so this is how we specify. If it is content, we specify the speech component, the audio component, the visual component, and then we have the transport, where we have different ways, which are the same as those used for only for the visual. And all right, and finally we have the source type, which can be real or synthetic. So this is what I have planned to talk about today, but this just to let you know that more is coming. And if you see so far, we have dealt with media, so text, speech, audio, visual, 3D model, and audio visual. But the next turn will be the data that we need for the metaverse. So for instance, we have an asset. So what? How can we represent an asset? Contract. There are different ways. For instance, in blockchains, we have a contract that can be written in language that are sometimes specific of the blockchain. Then we have discovery. You are in the metaverse and you want to search for something, but this is not the kind of searches that we do every day on the web. But this is a more sophisticated, and therefore we give the opportunity to express more sophisticated discovery methods. And we are also working on machine learning model, but this is much more complicated, and not much has been done so far. So thank you for your attention. We look forward to welcoming you in one of our projects, and we have many of them, as I have shown you. So this is the link you can use to join MPAI. And so this is our motto: join MPAI, share the fun, build the future. And indeed, we are sharing the fun, and we're building the future because we are providing standards in areas that are not being covered by anybody else. Thank you for your attention.